What's up, Algebra 1? We talked about point slope formula today, and then a lot of this homework has to do with a review of all the other stuff we were talking about. We got slope, we got point slope, we got graphing lines, and a little more practice of those things. So let's go ahead and jump into it. Slope formula, y2 minus y1 over x2 minus x1. So labeling it is helpful, x, y, x, y. And so we're connecting the y's together, so that'd be negative 12 minus negative 8. We're also doing negative 19 minus negative 11. So when we do this, minus and minus does make a positive. Negative 12 plus 8 is negative 4. Same thing here, minus and negative 11 makes positive 11, and that gives you negative 8. These divide to give you positive 1/2. So try that with number 2. We'll check your work tomorrow. And let me know if you have any questions. So what we talked about today is called point slope. Y minus y1 equals m times x minus x1. You use this when you're given a point and a slope and you're trying to calculate an equation that would go through that point with that exact slope. So for the first one, it's y minus y1. y1 is 0 for this problem. M, which is the slope, 2/5, and you're doing x minus negative 5. So on the left, we have y minus 0, which is just y. And I may take a moment to change the fact that this is minus a minus, which is going to make a plus. And when I distribute it, I'm pretty much done since there's nothing to move over. This is 2/5 x. And then we've been talking about how these 5s can cancel, and you should just get positive 2. Let's try another one, and you can try the next two on your own. Y minus y1 equals m times x minus x1. And we're plugging in the values that are given in the problem. So this is y minus negative 1. Slope is negative 2. And it's x minus 2. So this is your x1 and your y1. So on the left, I see minus and minus, which we can change to plus. Let's distribute and get negative 2x. Plus 4. Let's start finishing this off by subtracting the 1 over so that we now have y by itself. I have a slope of negative 2, and this will go through the point to negative 1. So you try these on your own using the same formula. So we've been talking about vertical and horizontal lines, and something that you need to really remember is that when y equals 1, you're trying to say that all of the y values for all the points on it are 1. For example, 0, 1, and 1, 1, and 2, 1. Basically, all of the x, y values, this one is always a 1. The reason why that can help you is because you can start plotting those points, and it becomes obvious what kind of line you have. 0, 1, 1, 1, 2, 1. Basically, you have all of these horizontal values that would be y equals 1. Now, the opposite is true when you're talking about x equals 3. In the x, y points that are all on the line, 3 is the same for every point. 3, 0, 3, 1, 3, 2. So 3, 0, 3, 1, 3, 2, 3, negative 1, 3, negative 2. So we have this vertical line. Its slope is undefined. That's something we talked a little bit about today. But all the points share 3 in common for the x value. So now let's talk about graphing something that's in standard form. First thing that I really like to do is maybe rewrite the problem off to the side so that you have more room to work. But the steps are often the same. Let's move x to the other side, subtracting 8x over here. And just make sure I don't put too many negatives there. Those never go together. So you have negative 3y equals negative 8x minus 9. And then next I need to use division with negative 3 and really pay close attention to the signs. This one cancels, leaving just y. Negative over negative makes this positive 8/3. Negative over negative makes positive 3. So if I'm graphing this one, let's go find 3. And I really can't go up 8 and over 3, but I do see how the line is oriented to make a positive line. So I'm going to go down 8 and left 3, and now I can connect those 2 points. So I've been talking about how you can test ideas because all graphing is input-output. This point is -3, -5. So if this point really is on the line, when I plug in -3 and -5, it should calculate the correct value of -9. So what is 8 times -3 minus 3 times -5? 8 times -3 is -24, and -3 times -5 is positive 15. Those values do in fact give you -9. So this line is graphed correctly. I want you to try number 10. Same idea. Do it on your own. Take 2x minus 3y off to the side and then solve for y to see if you can get the correct equation. Test input output with some of the points that you're getting. You should be good to go. Write the slope-intercept form of the equation of each line. Slope-intercept is mx plus b, because slope is m and intercept is b. So they've already given you the equation in point-slope form. A few things that you'll need to know for the first test is how to identify x1 and y1 from the equation. x1 is the 3 that's here. Y1 is the 2 that's right there. Now remember that the signs are not really the same in the points because in the equation it's a minus. And so it looks like they're negative, but they're really positive. And the slope there is 2. Now that's not important for this question, but it will be important for other questions. Let's go ahead and try to distribute to see what we have to get it in order to see it in slope-intercept form. So 2 times x is 2x. 2 times -3 is -6. We can now add 2 over, and we see that y equals 2x minus 4. Try number 12 independently, and we'll check your work tomorrow. Last 2 I won't do, because I'm wanting to see if you can do them correctly. This is mx plus b, slope-intercept form, and this one is standard form, ax plus by equals c. So I'm looking forward to tomorrow to see if that's something that you've mastered. Thanks for watching the video. Goodbye.